How databases operate at the fundamental level has always fascinated me. Like as I grew in my career as an engineer, and then I started going deeper into optimizations and trying to squeeze performance out of the barest minimum metal. I started getting more curious about what was going on beyond just the typical queries, like what happens when you do a select star, what happens when queries are executing concurrently and stuff like that. Like I'm really, really interested in databases, I'm not gonna lie. As to how they are operating at a fundamental level. Recently, I decided to read more and more about isolation levels, which I learned about some time back, but it never gets boring. And at each point in time, anytime I decide to try to learn it, I get a new perspective about how they work. So I came across this very beautiful article, very, very basic, like it explains the concept in a very nice format. This is on a Planet Scale blog, right? And it was written by Brian Morrison just in January, just on January 8, 2024, right? So it's a pretty recent article. Let me zoom in. So in this video, we are going to go through this article together. I'll try to provide further explanation to most of the things that we read here. Unfortunately, this is not going to be a coding session, so I'll not be doing some of the code stuff parts of this video, right? But I'm going to try and break down everything. This is probably going to be my second read of this article. I read through it, I skimmed through it just once, but this is really going to be my second read where I'm going to take my time and read it properly and then explain it to you in a way that you also be able to pick up something without having to go through this article on your own, right? I feel like there's a lot to unpack and there's a lot to learn. So let's get into it and make so my SQL isolation levels. Is it MySQL or MySQL? MySQL isolation levels and how they work, right? So in the early 1980s, computer scientist Andreas Reuter, I hope I had the name right, and few had coined the term ACID. I never knew that ACID was coined by scientists, right? Coined the term ACID to describe a set of properties related to database transactions designed to keep data stored reliably and with integrity. Now, if you know about databases, even on a basic level, you know that data integrity is very, very important, right? When you store A in the database, you want to make sure that you are getting A when you try to retrieve it later. When you store B, you want to make sure you are getting B when you try to retrieve later. When you add 1 to 1, you want to make sure you are getting 2 later, right? It's, like you need that type of integrity. Else, why do we need a database to start with? Okay, and then so let's go on. Most, if not all, modern database systems are built around ACID compliance. This is very true. Even though SQL databases are now trying to be ACID compliant, by adhering to these fundamentals, businesses can confidently trust the data within their databases, whether it's for a small project management app or a large banking system. Isolation levels, as well as the related concepts, are cornerstones that enable MySQL to fulfill ACID guarantees. In this article, we'll break down how multiple clients can work with a single database and maintaining data consistency by using isolation levels. So, just to give you a quick summary of what isolation levels are, if you've worked with MySQL or any other relational database, you realize that we have a concept of transactions, right? Transactions can be a group of queries executing as a single unit. Okay, that's usually it, or it can be just one query, stuff like that. In MySQL, almost everything is a transaction, all right? So when we talk about isolation levels, that it's like a transaction is like a sandbox That's how I choose to call it, like in simple terms. So you can have multiple sandboxes executing, right? But these sandboxes are trying to access data from outside the sandbox. All right. So now with isolation levels, what you are trying to say is that what type of data are these sandboxes allowed to see, or what are they not allowed to see or access? So they get out of the sandbox, right? You get the concept, right? Like we are both in our rooms doing our own thing, right? I'm here, there's another person in another room somewhere doing their own thing. We are trying to add 1+1, but what are we allowed to access outside the room? Okay, or at the point in time that we're entering the room, what are we allowed to bring into the room from outside the room? Okay, you get the concept, right? So that is what we call isolation. Okay, what can I do? The stuff that I'm doing here, can the other person see it? Does it affect what he's doing the other person is doing in his room? Okay, so these are some of the very, like, in plain language, what our isolation levels are. But let's go into the technicalities. So a MySQL isolation level is one of foremost that can be set on a MySQL session that controls how transactions should behave when executing concurrently. This concept relates directly to the isolation requirements of ACID compliant databases, which states that transactions should be executed in a way that does not affect other transactions. Depending on the isolation level set on a session, various locking mechanisms are used to manage which transactions have access to what data at any given time. This also determines the different inconsistencies known as violations that can surface when running multiple transactions concurrently. With that brief explanation on what a MySQL isolation level is and what benefits it provides, let's further explore the different isolation levels, transactions, violations, locks, and how they all relate to each other. All right, so in simple terms, like I gave the room example, imagine you have a bank account, right? And then you are adding, let's say you are trying to withdraw money from the bank account. Let's say you are trying to withdraw, you have 50 cedis or $50 in your bank account, and you are trying to withdraw, let's say you are trying to send money to someone. Okay, maybe you are trying to send $30 to somebody, and then another $30 to somebody, and then maybe another $30. You are trying to send three $30 from a $50 account, right? Now, in the moment where you issue the third $30, right, you are supposed to normally get you're supposed to normally get an insufficient balance alert that you cannot send because how much you're trying to send is more than your balance at that time, right? But imagine during the third one you are about to send, somebody sent you money, right? In that moment, okay, somebody sent you money, so now your balance actually was enough. Right now, the question is that during the process of initializing or during the process that your transfer was being executed, should you be allowed to see the incoming added balance, or should you not be able to access it? You get the idea, right? So you can either see insufficient balance, or even though you saw zero in the beginning, the money will still be sent, because during the process of the sending, another balance was credited to your account. Okay, so you get how important this concept is, right? Very, very key. Without it, you just end up destroying a lot of things, or if you don't have an understanding of actually what's going on in your database, you have like a lot of data inconsistency. So you need to know at which point in time what isolation level your database is running, so that you can predict the behavior of like your incoming and outgoing data. Okay, so before we go into more isolation level stuff, let's talk quickly about ACID compliance. I'm not going to spend too much time here because ACID compliance is another whole topic on its own, but just to give you an idea, since we've already mentioned it, right? So atomicity means that any number of SQL operations can be executed as a single unit of work known as a transactions, right? So transactions, like I said earlier, are used in MySQL to execute one or more statements as a group, okay, satisfying the atomicity requirements of an ACID compliant database, right? So when you are in a transaction, right, the idea is that we are different queries executing, we are different actions being performed, right? But all of us are committed at the same time. Like all of us should be committed when everything succeeds. Okay, so it's like you are doing the mixes in memory, you are adding, you are updating. It's like virtually you are like, just I'm trying to explain this in simple sense. Like you are doing all your update queries, your insert queries in a transaction virtually, right? Only when all of these succeed do you apply the changes as one unit to the database, right? And that is what a transaction usually is. So it says here that when statements are executed as parts of a transaction, no data within the database is actually changed until the transaction is committed. Alternatively, if something goes wrong within the transaction, you are given the opportunity to roll back any changes, which can prevent issues with the underlying data if committed. By default, MySQL has auto commit turned on, which means that individual statements issued are automatically committed without you having to manually start a transaction, right? So committing is committing is a whole topic on its own. When we say committing, what actually is to commit a set of query or to commit a transaction to the database? What is the whole concept of committing? It's another thing, right? But take it this way, in simple terms, just take it this way. You have a word editor open, right? You have a word editor open, let's say Microsoft Word, Notepad, whatever it is. You can type in some. You see, once you start typing in some stuff, you get this star at the end, or depending on the editor you are doing, you see clearly that you have unsaved changes, but you have actually typed the stuff. It is only when you press Control S or you go to file and press save, that is when the things that you've actually typed are committed on the disk, such that when you close the file, you can still come back and retrieve it later. All right. If you are typing and then you don't save and you try to close it, Microsoft will probably tell you that you have unsaved changes. You want to save before closing, stuff like that. It means you've made some changes and you've not committed it, right? So that is the idea of committing. So you have queries, you've modified your database, you've moved things around, but you've not written it to disk just yet, right? So it's like that. But then if you are executing a query and you don't wrap it in a transaction, or you don't execute it in a transaction, MySQL automatically commits it. So that's what we call MySQL auto commit. So it's default turned on, which means that all the individual states. So when you do a select star, when you do an update statement, it gets committed immediately the query finishes running. You understand? So I hope you get the idea of the commit, right? So let's talk about the consistency part of atomicity. So consistency ensures that the database can confidently be moved from one state to another, avoiding any adverse effects or corruption of the data. This is done by enforcing things like constraints, cascading effect, triggers, etc., right? So imagine that you have a product table and then you have an orders table. Right now, products can have many orders. So, but imagine a user comes into a database and deletes a product. Now, what happens to the orders that the product has, or the other records that the product is related to? That is the topic of consistency. Okay, how you deal with that is what will determine uh, whether your data is consistent, because you don't want to have orphan children. So then when you talk about consistency capability of a database, you are trying to talk about what type of features or what type of functionality does the database provide to help ensure that this integrity and this consistency is actually preserved. Okay, so that's consistency. Okay, then the next is isolation, right? So that is the main point of this article. So isolation states that transactions are executed independently and in a controlled and ordered way, since many clients and threads are often connected to a single database and executing transactions concurrently. You have an online store, you have a product that has quantity of one left. Two people try to order the same product at the same time. How is the transaction process? You know what happens? That is isolation. Okay, so durability simply means that that's the next one. Durability simply means that once a transaction completes, the data can survive system failures and outages by storing the data on a persistent storage. Memcache, for example, stores all of its data in memory, so it will fill this requirement. All right. So once, for example, if I log into my account, my YouTube account, for example, and then I log out, and then my laptop loses power or whatever it is, I come back out, I can still have access to my YouTube account, right, with all my data. Right, YouTube database is durable. All right, so even when you lose power, or even when YouTube servers lose power, they don't lose that type of data. Why? Because their data is durable, or the database system they are using is durable. That's what we mean by durability. Okay, so now we are going to jump into this music store, right? Because I don't want to make this video too long, we are going to I'm going to try and breeze through as much as I can. Okay, so uh, the remainder of this article will use a common example of an online store that specializes in selling units of an antique audio medium known as compact discs or CDs. The schema will be relatively simple with four entities: products. So we have the products entity, right, or the product model that will contain the available stock of a given CD, including the name, artist, and quantity available. The unit status will list the quantity of CDs for any product that are currently available on hold or pending shipment, right? The customer transactions will contain records of when sales are made. Then the customers will list all of the customers that have purchased CDs, right? So this is like a diagram of it. So realize that over here we have the let's increase the zoom over here a bit, right? So realize that over here we have the customers table. The primary key will be the ID and then the name. Then the customer has many transactions, which is the customer transactions table. So you realize that in the customer transactions table we have the customer ID key and then the product ID, right? So a transaction is defined by who bought it and what they bought, right? And then at what date and time, and then how many quantity did they buy, and then the total cost of their purchase, right? And then we have the products table, which also can have many records in the customer transactions table. Okay, then in the unit status table we can see the status of the product. So that is what has been stated here. We'll list the quantity of CDs for any product that are currently available on hold or pending shipment. Okay, so we know we have on hold, available, or pending shipments based on the status. Okay, so isolation violations, the meat of this is where things start to get fun. Okay, so violations are various read phenomena that can occur when transactions are executed concurrently and are specifically what isolation levels seek to prevent. Depend on a selected MySQL isolation level, each of which will be covered later in this article. One or more violations may be permitted in the name of database performance and query consistency requirements. Now let's take a look at the three common violations you may encounter while building around your database. Okay, so first of all, we need to talk about what isolation violations are, and then we'll come and talk about the isolation levels. So the isolation levels are sort of the strategies implemented by MySQL to help solve the isolation violations. Okay, now when we say violations, it means that isolation violation, we are saying that, okay, when multiple transactions are executing, they should be isolated in a good way such that their data will not affect each other, or other transactions will not be reading outdated data or data that has not been properly committed, stuff like that, right? And there are violations for that type of standard. Okay, so things happen that do not let us maintain consistent state. And these are some of the things that happen. So the first one is dirty read. So a dirty read occurs when a query within one transaction returns inconsistent data because it may read a new version of the data that has not yet been committed to the database based on another concurrent transaction. To demonstrate this, let's say that two customers are interested in purchasing the same CD and two units have a status of available. One customer purchases both units, which prompts the system to move the status of the two units to sold, not shipped, before reducing the quantity available. At the same time, the other customer checks the inventory to see if the CD is available. The system returns that there are still two units available. The transaction used to update the status for the CD is as follows. I'll give a quick recap of this, right? So start transaction, right? So this is the beginning of the first transaction, right? So update unit status, set quantity equals the quantity plus 2, right? Where product ID is equal to 20 and status is equal to sold and not shipped. Update unit status, set quantity equal to quantity minus 2, where product ID is equal to 20 and status is equal to available, right? So assuming the following query is executed during the above transaction just before the commit is called, the result will be 0, given that the transaction is not finished yet, right? So select quantity from unit status where product ID is equal to 20 and status is equal to available. Okay, so here is the thing. Imagine this transaction is executing, right? First of all, we updated the quantity, we added 2 to the quantity, and then we updated the status to sold and then not shipped, right? And then we updated the quantity again to we deducted 2 from the quantity, and then we said now the status is available, right? Now, before this commit was run, we decided to query the database in another transaction, right? And then now this transaction decided to select quantity from unit status where product is 20. Now remember, if 2 has been deducted from the quantity, then it means you are left with 0. Okay, but technically this transaction right here has not been committed, so we cannot say for sure that will be the final state of the record. You get it? It's like opening a Word file, like I said, typing in the quick brown fox jumps over the lazy dog, and before I save changes, maybe another file somewhere says that, oh, you have written the quick brown fox jumps over the lazy dog when I've not saved changes. So what if I decide to delete everything I've typed? Then you have read something wrong. Okay, so then we have what we call the dirty read. You read something that was not committed. You read something that was not finalized. Okay, so let's look at the timeline of what the transactions will look like and the result. Okay, so this is a breakdown in a diagrammatic form for you to understand. Okay, so we start a transaction, we updated the unit status, set a quantity, we added 2 to the quantity, right? And then we deducted 2 from the quantity as well, right? And just before we committed, another transaction did a select, right? So now this transaction at the right, which did the select, is now going to read that there's 0 quantity. Meanwhile, this has not been committed. So that's what we call a dirty read. Okay. At first glance, this may not appear to be an issue since the database reflects that the values of 2 rows in the unit status available in the unit status table after both updates occurred. However, if that transaction issued a rollback instead of commit, the data returned will be inaccurate since the changes were reverted after the customer was shown that no units were available. You get the idea? So there wasn't certainty that this update will actually be finalized. Okay, so if this is rolled back, then whoever is requesting for this data will be receiving the wrong information, because if this is rolled back, then it means that technically there will still be some stock available. Okay. This is getting interesting. Sorry for the cough. Okay, so guys, the next thing is non-repeatable read. Now remember, we are still on isolation violations. We've talked about dirty reads. Now, non-repeatable reads. Non-repeatable reads occur when a transaction with multiple select queries read the same rules within the transaction, but the data within those rules is different between select, since another transaction has modified the data in that time. Okay, so for this example, the store owner is looking to read the number of units available for a given CD across two select queries. However, they receive different results between those two statements since it occurs at the same time that a customer is purchasing the CD. This is so interesting, right? So now look at this. Look at the comparison for this. In the first instance, right, we're doing an update. We're updating the records. We didn't commit. Then another transaction decided to read the information we didn't commit as the updated record. That's a dirty read, right? Now, the non-repeatable read, we are in a transaction. At the start of the transaction, we selected some data. During the course of the transaction, another transaction updated. So let's say, this will explain further, but like during the course of the transaction, another transaction somewhere updated the data we just read. Okay, then we came back later and then did another select query, and then now we got two different results, right, based on the beginning, the first one we did and then the last one we did. Okay, so now let's look at this transaction. So get the current available quantity of the CD. We'll return 15. So select quantity from unit status where product ID is equal to 20 and status is equal to available. Now the same query will now return 13. See the transaction below. So we'll go to this transaction and see how it does. Okay. So let's go. Here's the same transaction using the previous example to update the inventory of a given CD when it is purchased. All right. So we have this transaction, select quantity from unit status where product ID is equal to 20 and status is equal to available, right? Now, we come and do the same transaction again, select quantity from unit status where product ID is equal to 20, right? But now, before this one is run, something else was executed. Okay, so over here, we said update unit status, set quantity equals quantity plus 2, where product is equal to where product ID is equal to 20 and status is equal to sold and not shipped, right? And then in the second one, we said that deduct 2 from the quantity where the status is available. You get what's happening. So over here, we selected the first time, we got the normal 15. We selected the second time, right? And then this time around, another transaction had already updated the first one we read, the records to has already deducted 2 from it. So now on the second select, we are getting a totally different result set, and that's a non-repeatable read. Okay, so now let's look at this again. Okay, because these two transactions are executed simultaneously, they overlap each other, resulting in the second statement in the first transaction returning a different value. Okay, so the first transaction is started at the left, the second one at the right. First one started, they select quantity from product. It's okay, return the result. Before the second one was run, this other transaction updated the same quantity field that the first one read already. So now this added some stuff to that particular field, and then after it added, it committed the changes, and then this one came back and read those records again. Okay, so the second query will return a different value than the first, even though they're identical, and it's not supposed to be like that in a transaction. Okay, because imagine you actually run a query and then imagine you actually did your own updates in this particular transaction, the one at the left, and then you need to make sure that the records are consistent. And then now this other transaction has already affected the queries that you made on the left. Then it means you are basically going to be doing wrong stuff. Okay, yeah, you're going to be doing wrong stuff, and that is what we call a non-repeatable read. So the idea is that whatever select results you got at the beginning of your transaction, it should be consistent with all your other queries, and then the last select that you do at the beginning of at the end of the transaction. Very, very important. Okay, so let's go to the next isolation violation. So we talked about dirty read, we've talked about non-repeatable read. The next one is phantom read. Phantom read is also a very interesting thing, right? So phantom reads occur when the actual rules returned between select statements in a transaction differ because another transaction has inserted rules before the first can complete. Okay, so this is the insert version of the non-repeatable read, right? So for the non-repeatable read, we are saying that another transaction updated the records. But for the phantom read, we are saying another transaction inserted records into the data set before we got a chance to finish. Okay, so let's jump straight into the diagram. Okay, so start transaction. We did a select count star from products. So let's say we did a select count star and then we got 50 products. Then right before we did another select count star, another transaction elsewhere inserted another product. So it means right now, technically, the number of products is no longer 50, it's 51. Okay, so what we started with and what we are ending with is different, and it's not supposed to be so. So that's like unless it's by design, which we talk about, but that's not supposed to be so unless it's by design. So then we have what? An isolation violation. Okay, so let's talk about locks. Now that we know the isolation violation, let's talk about locks and how they relate to isolation. I'm sure you've heard a lot about locks. So transaction isolation is enforced by using various type of locks or flags that can be set on rows and tables to prevent data from being read or modified. Okay, so MySQL will use one of two types of lock depending on the isolation level: shared or exclusive locks. I love locks. I love locks. I love locks, seriously. So take locks like so. Imagine going to the restroom. Okay, imagine you are using the restroom. Okay, and then you enter the restroom and then you lock the door. Now, once you lock the door, you are saying that, hey, nobody is allowed access to the restroom, so I'm done, and then I leave. Okay, so that's an exclusive lock. Nobody can enter, nobody can do. So nobody can come and do what they want to do. Then nobody can also see what's going on. It's like you are locked up. Okay. Then we have the shared lock. Okay. So take shared lock like the general, let's say, restrooms, okay, where people can come and then actually see what's going on and then wait for one person to finish for them to also replay the person and do whatever they want. Okay, that's like the concept of a share lock. And so let's go into the technicalities. So a share lock is one that can be created by transactions for ensuring the data they are reading doesn't change. So when a share lock is created on a row, that row is still readable by other transactions. Other transactions, however, cannot modify the data within that row. Any number of transactions can create a share lock on a row, and all locks will need to be released before the data can be modified. So, like I said, other transactions can see what you are doing, but they can't touch it, so you are done. You understand? So, to solve the problem of the different selecting that within the beginning, once I decide to, let's say, select something from a row, or maybe select from this where ID is equal to that, I obtain a share lock on that row. Right. So when I obtain a share lock, it means that other transactions can read from that row as well, but they cannot make changes to that row. So I'm done with my transaction. So that's share lock. So let's go to exclusive lock. When a transaction creates an exclusive lock on a row, only that transaction can read or write the data. If another transaction attempts to read or write the data to that row, it will be prevented from doing so. This is especially useful during transactions where you expect data to be updated to prevent some of the violations as outlined above, right? So, like I said, this one is exclusive. It's like you can't see, you can't pick, you can't add, you can't take, you can't add, you can't do anything. It's locked, so I'm done with it. Okay, so that's an exclusive lock. Then we have what we call the gap locking. A gap locking is a special type of lock that is used by MySQL to prevent phantom reads. Okay, so we said that phantom reads, it's a it's the insert variation of the non-repeatable read, right? So gap locking will use criteria in where clauses to lock the space around the read data, preventing rows from being inserted that may alter the query if it's run a second time. So let's go further into the gap locking to just get an idea of what we're talking about. So to demonstrate this, let's use the music store example and assume the owner wants to run a sale on any of the CDs released in 1999. Okay, so we start a transaction. Select star from products where release year is equal to 99 for update. Right now, update product set cost is equal to 800, where release year is equal to 1999. Okay, so if an employee decides to add a new CD to the products table that was also released in 1999, MySQL will make that transaction wait until the previous one had completed before proceeding. Okay, so we start a transaction. We select star from products where release year is equal to 1999. Okay, we are selecting it for update. So then we said update product set cost is equal to 800, where release year is equal to 1999. Okay, so over here, this query will wait. Okay, because then you are trying to, I'm working on a product set for products that belong to the year 1999. I'm trying to fetch records for that product and do some updates on it. And that transaction too is else you're trying to insert new records, new product that belong to that same year. Now SQL will create a gap lock, right? This prevents the second transaction from inserting a new row that will alter the results of the first transaction. Okay, so you realize that over here, you are not, unlike the shared and exclusive lock, you are not necessarily updating or working on a single row or a single group of rows, right? You are sort of updating certain product that fits a certain criteria. So MySQL detects that you are doing this query you are doing is affecting a bunch of rows that belong to a certain criteria. So let's hold on to any other incoming transactions till you are done. Okay, so that is the idea of the gap lock. So controlling log, it's worth mentioning that select statement can actually be altered to indicate that MySQL should place a specific type of lock on a row. By adding the for share keywords at the end of the select statement, MySQL will create a share lock on that row, and using the for update keywords on the end of the statement, select statement creates an exclusive lock. Here is a modified version of the dirty read example from above that uses a locking read. This approach will prevent another transaction from reading the data before it was updated. Okay, so start transaction, select start from products where ID is equal to 24 update. Update product set cost is, so anytime you see this for updates, okay, it means that you are saying that, hey, MySQL, put an exclusive lock on this particular product for me. Nobody should be able to touch this product, make changes to it, or even read from it. So I'm done with whatever I want to do. Okay, so that's the concepts of the exclusive lock and how you can, one way you can control the locks. All right. So let's talk about the 4 MySQL isolation levels, like the things that are implemented, that are inbuilt in MySQL that helps control all of these dirty reads and non-repeatable reads and phantom reads that we've talked about. Okay, so isolation levels instructs the database engine on how to manage multiple transactions being performed concurrently. Now, in the real world, remember that you are not going to have just 2 transactions being executed. You're going to probably have thousands and hundreds of thousands or millions of transactions being executed at the same time. right? So then at that scale, the little mess up can cause a lot of issues. All right, so let's look at what MySQL does to help you. So read uncommitted. So this is I don't know why anybody will use read uncommitted, but it has its use case. Read uncommitted has its use case, and let's talk about it. So read uncommitted is the lowest isolation level, effectively allowing all violations. Like everything we talked about, read uncommitted. I don't even know why it's called an isolation level, but well, it is, right? So for read uncommitted, you are saying that, hey, in the course of a transaction, I should be seeing any updates going on anywhere that has not even been committed or finalized. That's read uncommitted. Okay, so this mode should be used when performance takes priority over data consistency. All right, deviating from the example outlined above, one situation where this might fit well is in a social media app. When finding the number of likes on a popular post has many social media apps shorten their numbers after a certain point, example 1k over 1,000. If a client needs to know how many likes the post has, returning an approximation over the exact value is usually acceptable. Okay, so like you maybe a popular celebrity makes a post, a lot of people are liking. If like multiple people are also viewing the post and you try to obtain locks for all of these reads, you are going to like take a huge performance hit, right? So in that case, you can say that, hey, everybody should see what everybody should see. Okay, so you don't even try to create any type of logs, because then at a certain point, maybe accuracy is not so important as compared to like people being able to just get an estimate of how many likes the post actually has. Okay, so we committed. So for this one, it says that this one is like a very strict version of the it's like a very strict isolation level. Basically, you are saying that the only thing that the transaction should see is changes that have actually been committed, right? So let's see this. In this mode, each row modifier will create a version of that row which is tagged by the transaction ID. Subsequent operations on that row will use the version belonging to that transaction. Each select within transaction will create and use a fresh snapshot version of the read rows at that point in time. This means that if a row is modified and has been committed by another transaction, the next select will create a new snapshot, which now represents the latest committed version of that data. The key difference between read committed and read uncommitted is that read committed will always use the latest committed row, whereas read uncommitted will use the latest version of that row even if it hasn't been committed yet. This mode will still allow non-repeatable read and phantom read violation. Okay, so you get the idea. So for the read committed, there's a little bit, it still causes issues between like transactions or between queries in a transaction, because imagine you select count star in the beginning and then you get 50 products, and then in the course of the transaction, another transaction added a new product and now it's 51. Okay, and then it actually commits and finalizes. Now in transaction number 1, when you do another select count star, you now get 51 instead of the 50. So ultimately you still have like a non-repeatable read. You still have a phantom read in that case, because in the course of the transaction, another transaction actually inserted a record. Okay, the only thing is that for this one, you are reading for read committed, you are at least getting committed changes, unlike the read uncommitted, where whether the change is committed or not, you still pick it up. Okay, now let's talk about repeatable read. Okay, so repeatable read, thankfully, is the default MySQL isolation level used for all connections unless configured otherwise, right? With InnoDB's MVC with InnoDB's multi-version currency control, right? Concurrency control, a row may have multiple versions at any given time, depending on open transactions, right? In repeatable read level, queries will use a consistent snapshot of the data. So when a transaction is started, the idea is that whatever information I picked at the beginning of the transaction, that's like a snapshot, and that is what we use for the entire transaction. Okay, so a repeatable read level queries will use a consistent snapshot of the data, pinning the reads to a single transaction ID throughout the transaction. Compare that with read committed, where reads always pick the latest committed version of any arrow, and where subsequent reads may return different results. With locking reads, the method that MySQL uses to log the data depends on whether a unique index is used, right? So with locking reads, the method that MySQL uses to log the data depends on whether a unique index is used. If an index can be used based on the where condition, MySQL will only log the necessary rows that match the query. If an index is not used and the table is scanned, MySQL will log all of the rows it reads, regardless if they match the where, as well as perform gap locking to prevent inserts that may alter the data if the query is run multiple times. Using the repeatable read isolation level prevents dirty reads, non-repeatable reads, and phantom reads. Okay, so for this is really beautiful from SQL. This is really beautiful for MySQL, okay, because then what you are saying, what this is telling us is that once you start a transaction, MySQL does a lot of things to make sure that what we get in the beginning is what is maintained across the entire lifespan of the transaction so it's committed, right? So it uses things like locks based on the index that you've provided. Okay, so if there's an index and then it sees that it can be used based on the where condition, MySQL will lock only the necessary rows, okay, or maybe it can, depending on whether if there's no index, like and then it realizes that okay, the queries that you are trying to fetch, it can apply gap locking, then it will also apply gap locking on the records that you are doing. So MySQL applies a lot of things to make sure that whatever transaction you are executing, your data remains, the integrity of the data is on point, and this is actually the default setting. Okay, now the last one is serializable. Setting the isolation level to serializable also prevents all violations, but it has the most performance impact on your MySQL server. So this mode works exactly like repeatable read, but implicitly creates a shared lock on all select statements, whether you use for share or not. Due to the excessive locks used, there's a greater risk of deadlocks occurring. Okay, so if the isolation level of the database is set to serializable, it means that immediately I read, there's a share lock on that read. Okay, so you can no other transaction can no other transaction can make any changes to it, right? So if you have millions of transactions, they all have to be executed one after the other as the share locks are actually released. Okay, and that can cause an issue. Okay, so how to set the MySQL isolation level, right? So it depends on your use case. Maybe you realize that the default a repeatable read is not something that actually works for you. Maybe for a particular database, you think that maybe the read uncommitted, like we said in the social media use case, will better work for you. There are ways you can set it manually. Okay, so this is the query for that. Set transaction isolation level, read uncommitted. Set session transaction isolation level, read committed. It's optional. Then it says that session is also optional over here, right? So you can either set it on a particular transaction session request or a particular connection, or you can set it globally, consistently. So that is also one. If you have the connection admin user permissions, you can also use the following command to set the default isolation levels across the server. This only affects future sessions, and any session is open to change its own isolation level regardless of what the server has set it to. So set global transaction isolation level to serializable. Okay, so finally, isolation levels can be configured prior to MySQL starting by using the -- transaction isolation equal read uncommitted, or in the configuration file transaction isolation. Then you specify whichever you want to use, whether repeatable read, whether read committed, whether read uncommitted, whether serializable. You can specify there as well. Okay, so and then in conclusion, as you can see, MySQL uses a combination of several different concepts to ensure that it's asset compliant, right? That is why relational databases are, Mama, I love them. Okay, making a reliable and a trustworthy database. Many of these concepts revolve around transaction isolation and the various levels available, allowing you to fine-tune the balance between safety and performance. This was this was a beautiful article. It was an amazing article. It really did well at explaining in simple terms what the isolation levels are. I hope you learned a lot from this video. Now, anytime you are developing something, a very delicate system like banking, like finance, like health, like some very delicate mission critical stuff, you should have this isolation thing in mind, and then try to understand how it affects whatever database or whatever system you are about to build, so that you'll be able to predict when the unforeseen happens. Okay, you'll be able to optimize for performance too as well. All right, guys, so thank you so much for watching this video. This was a long one. We learned a lot. We went through an entire article, and if you stay to the end of the video, I appreciate you. And I hope, let me know if I made any mistakes, or I probably missed on explaining something. Let me know in the comment section below. I'd like to learn from you. I'd like to hear from you. And if you haven't subscribed, please subscribe to the channel and then like the video for the algorithm. Thank you very much, and then I hope to see you in the next one. Bye bye.